Okay, we're going to get started. Hello, everyone. Good morning. My name is Mackenzie Woodman. I'm the application specialist here at SpectralEvolution, and today I'm excited to present about some advancements in non-destructive leaf and surface measurements that we've made at SpectralEvolution. So this is going to be a relatively shorter presentation here today, but we're going to go over all of our different ways of measuring leaf reflectance as well as surface reflectance, and announce a new accessory. So SpectralEvolution is the leading manufacturer of high-quality UV, Vis, NIR spectrometers and spectroradiometers. We were established in 2004, and we're located in Haverhill, Massachusetts, just outside the Boston area. Our primary applications are in hyperspectral applications, remote sensing and vegetation, mining and geology, as well as photonics and calibration transfer. We have many different applications in all of those sectors. But to start off, I'm just going to present on what is a spectrometer. All of our instruments are spectrometers, and some of them are spectroradiometers, which means they get a radiometric calibration. So a spectrometer, or spectroscopy, is the study of the electromagnetic spectrum as emitted or reflected by various materials. The electromagnetic spectrum is a representation of electromagnetic radiation and how it's defined by wavelength. So a reflectance measurement directly relates to the materials and chemical structure and bonds of that material and how that light bounces off of it. Our spectrometers all operate, or primarily operate, within the 350 to 2500 nanometer range. And they can all, or then the spectroradiometers like the NatraSpec series can get a radiometric calibration, which means they can measure the amount of light or the amount of energy that's being measured by the instrument. So being able to identify materials by their chemical structures is very important in soil applications, vegetation applications, as well as identifying minerals. If you're in this presentation, you're likely using it for one of those applications. So we have a host of different spectrometers that are primarily separated by their resolution. So this is our NatraSpec series. So these are spectroradiometers, so they can do energy measurements. And so we have a standard resolution instrument, which is the RS-3500. So that was industry standard for many years, but in recent years, we've made great improvements on our instruments. And we've announced the NatraSpec and the NatraSpec Plus. This improves our spectral resolution without sacrificing signal-to-noise ratio. And for that instrument, we get 2.7 nanometer resolution in the Vis, 5.5 and 5.8 in SWIR 1 and SWIR 2. Now, the improvement that we've made with the NatraSpec Plus is an internal battery, as well as a smaller form factor. So it's lighter, more easy to transport in the field, and it has an integrated battery inside the instrument that you can hot swap, so you never have to disconnect from the instrument. So that is our most modern instrument, and it's the new standard for remote sensing and field measurements. We also have the NatraSpec Ultra, which gives the highest resolution for field spectrometers on the market, with a 1.5 nanometer resolution in the Vis, 3 and 3.8 in SWIR 1 and SWIR 2. So that is for any applications that you need the absolute best resolution. So for identifying different minerals or getting the best response for different nutrient analysis and vegetation, that would be a great product for you. So some of the challenges of remote sensing are, with satellites, you're going to be limited either spatially, spectrally, or temporally. And so that's why it's so important to have something in the field that can be deployed at any time and at any frequency that is needed for your study. So oftentimes these instruments work in concert with the satellite or a drone that may have a little bit more limited in any of those categories. The other limitation is that if you're working in any areas that are densely forested or have intermittent climate or rapidly changing climates, when you're using an airborne device, you're going to be limited by the canopy. And so if you want to get sub-canopy measurements, a field instrument is very important. So oftentimes our instruments are used in concert with these to do ground truthing or to validate what those satellites are generalizing with their resolution. So it's one of the most common applications of our instruments. And as you can see here, this is just another representation of that. If you're taking outdoor measurements on the left, we have a black body curve, and we have the when you're using the sun as a illuminator or your energy source, you're going to have two water bands where the atmosphere is absorbing 100% of your signal there. So you're going to end up with noise there. So being able to deploy a field instrument that has its own internal light source, if you're looking for a feature that's in those ranges, it's good to have an instrument that can target it with its own light source as well. And on the right, we're just showing that a lot of these satellite images or drone images are going to be very optically complex, and being able to decompose those with data from the ground is an important feature. So what are some of the applications for leaf reflectance and surface reflectance measurements? Like I said, I covered some of the remote sensing applications. There's many different applications in climate research, classification and identification of vegetation or invasive species, crop health for precision agriculture, also plant science if you're monitoring stress or red edge response or water content within different plants, or how they're maintaining the plants or whatever regiment they're on. Environmental research, forest canopy studies. These are all different ways that leaf reflectance measurements can be used for industry and research. So I covered some of the benefits of using our new NatraSpec Plus. We've improved greatly the size and the weight, and it's also it's also compatible with our SensaProbe, which will give you distance to target, live field of view, as well as some other metadata like integrated GPS system, solar angles, your optic angle. All of those can be integrated onto the NatraSpec Plus, and it also has all of the auto optimization steps that we have in all of our instruments. So with our instruments, anytime you take a scan, it will have an auto optimization step where it will automatically take your dark correction and take a quick scan and define all of your integration times for each detector. So you can think of that as setting the optimum aperture time for a camera for every automatically for every data collection that it does. So it's an important feature for data quality and maintenance of data quality. Now, for leaf reflectance spectroscopy, leaf reflectance measurements are used in a wide variety of different applications like evapotranspiration, plant health. Targeting the reflectance will allow you to target different kinds of nutrient analysis, total carbon, total nitrogen, things like that. And we have a lot of different ways to take reflectance measurements off of these materials. And you can go as targeted or as broad as you want. So the most broad you would get with a field measurement is a standoff measurement. So using a lens or the bare fiber to take a standoff measurement using the sun as an illuminator. Or then you could use the leaf clip to take a targeted within a few nanometers. Or if you're targeting pine needles, you can use the pine needle adapter. And so what we're introducing today is our new surface probe. So the surface probe is a non-destructive sampling method. So similar to the leaf clip, it has an integrated tungsten halogen light source in the handle, and then that light source is sent through a fiber optic cable so that it eliminates any of the thermal components that are reflecting off of your leaf. So you're not going to dry out your leaves, and you're not going to damage them through prolonged sampling. And this accessory is made to be a one-to-one comparison between field measurements and lab measurements. So all of the optical geometries and the light source are maintained between the leaf clip and then this surface probe. So this will allow you to put it directly onto your samples. So streamlining, it also has the triggering button. So that'll streamline your sampling in the lab. And so we have a lot of customers that are trying to catalog older leaf samples or pressed leaf samples. All of these tend to be dried out and more brittle. So it was very important for them to be able to scan these leaves without manipulating them very much. So by making the leaf clip with the non-destructive components to it, be able to scan in sequence across a page was something that was very desirable. So we designed this to accommodate for that. It can also be used for building spectral libraries for leaves, as well as scanning any flat materials like plastics or cloth or any other kind of leaf or material that is flat. We've also built a stand to make sure that for repeated measurements that the orientation is going to be the same between measurements. It also has the same connections as all of our other accessories, so you can quickly switch between taking regular leaf clip measurements and then taking measurements in the lab here. So like I said, this is primarily for or designed for cataloging. So we have a lot of customers that are doing catalogs of many different species, and this will allow them to incorporate that into their leaf lab and then go out into the field, take spectral scans in the field of a bunch of different vegetation, and then go back into the lab and have a one-to-one comparison with this leaf clip versus the surface probe versus the leaf clip. And the stand is optional. You can hold it in your hand, but the stand will allow you to create the same geometry every time and make sure that it's on a flat surface and not getting any stray light from the room. And then this is just showing our leaf clip that we've presented before. Our leaf clip has a compatibility with the pine needle adapter on the right here, but it also has a white plate incorporated into the end that you just spin it around to take a white reference. But what we strive to do here is create accessories that streamline sampling. So we have a trigger button that's the same on the lab version that will trigger a target scan. And then we have that swivel on the end that will give you your white reference measurement. And all of this works with our Darwin software that just operates the instrument and allows you to take scans and catalog them. You can create spectral libraries for comparison in the future and compare them to your, so you could build up the library in the lab using the surface probe, then go out into the field and compare to that with a one-to-one geometry and use EasyID to match between leaf analysis. So you can do things like chlorophyll content and things like that. And the benefit of our pine needle adapter is you can target an individual leaf as opposed to a bundle. So arranging pine needles in bundles has a lot of different limitations. It increases mutual shading of adjacent leaves, multiple scattering, and reabsorption of the pine needles. So the best way or best practice for scanning a pine needle would be to measure one at a time. And so you can be as targeted as you want with our instruments. This pine needle adapter can be used for the surface probe as well. It fits the same way. And yeah, so the pine needle adapter is the most targeted way you could take a leaf reflectance measurement. And then we also have an RT sphere. So the sphere measures all reflected light off of a sample at all angles. This is known as total hemispherical reflectance. So this would be best used for any samples that have gloss or very angular features. So if you have a very dried out leaf or something similar, this will measure the light in all directions bounced off of the sample. So it'll give you a leaf reflectance measurement that can be better trusted, or if it's waxy and you get more specular reflectance, this would be the best way to measure something that's very specular. So key conclusions is that SpectralEvolution provides the highest quality non-destructive sampling for leaves and flat materials. We listen to our customers and innovate to create new and easy to use accessories for your research, and we combine these quick attached accessories with our Darwin and EasyID software to create a complete ecosystem for research in any field. So I'm going to open it up to any questions. You're welcome to email me with any questions, but thank you very much for attending, and I look forward to the next one. Thanks.